Folks, we're on Unit 2, Assignment number 2's notes. You should be right here. This is in your notes packet, your pink packet. This would be on page 5. Okay, so the first thing we're going to do is we're going to make what's called a flowchart showing congruent triangles. So here you can see in this picture, we have two triangles, LAS and POR. We have some information that's given. We're told, given means that you're told this information, that angle L is congruent to angle P. We're also told that angle S is congruent with angle R. And we're also told that side A to S is congruent with side O to R. And what we're going to do is we're going to prove that triangle SAL, so the triangle on the left, is congruent with triangle ROP, the triangle on the right. And we're going to use a method that we're going to call a flowchart. Okay, so what a flowchart is a flowchart is a succession of ovals that kind of break down the thinking process of what you would do in order to show that two triangles are congruent with one another in this case. And I have done this, I've done this flowchart ahead of time, so I already know what it looks like. But when we are done with this flowchart, the flowchart will consist of 4 ovals. Okay, and the idea behind this is that what you do is inside the ovals, you write information that you know is true. And then underneath the oval, you write the reason how you know whatever is true about what you write on the inside of the oval. Okay, and typically when you do a flowchart proof, the first row of ovals will always come from the given information. So in this top left oval, I'm going to write the first given information, that angle L is congruent with angle P. Okay, so I'm writing, this is a statement of fact inside the oval. We always write statement of facts inside the oval. And then underneath the oval, I write, how did I know that angle L was congruent to angle P? Well, I knew that because that was given to me right there. Okay, so I just wrote that given right there. Then I'm going to go to my picture and I'm going to mark that angle L and angle P are the same by putting those arc marks with that slash in it, or that mark tick in it. Okay, then I'm going to go to the next oval. Okay, I'm going to write the second given, which is angle S is congruent with angle R. Okay, so that is a fact. I know that angle S is congruent to angle R. It says it right here. And then underneath the oval, I'm going to write in my flowchart, how do I know that that's a fact? Well, just like the previous oval, that was given to me as well. So it was given to me the fact that angle S was congruent to angle R. And then I'm going to go over and I'm going to mark in my picture that angle S and angle R are congruent. Okay, and then I'm going to go to my third oval, and in the third oval, I'm going to write the third given, which is side A to S is congruent with side O to R. And underneath the oval, I'm going to write, how do I know that's true? Okay, and that, just like the previous ones, were given to me as well. Then I'm going to go over to my picture, and I'm going to mark that side A to S and side O to R are congruent to each other. Okay, now, all 3 of these ovals in my first row lead me to the conclusion that triangle SAL is congruent to triangle ROP. So whenever you're doing a flowchart proof, and this is the first one we've done, but just start being aware of it, the very bottom oval, inside the oval, you're always going to write whatever you're trying to prove. So I'm going to put what I'm trying to prove, that triangle SAL is congruent to triangle ROP. Now, remember, when I write it inside the oval, that means that becomes a fact. And then outside the oval, I have to give the reason why that fact is true. So how do I know that triangle SAL is congruent with triangle ROP? Well, these three ovals lead me to that conclusion. And you can see that the triangles are congruent because there are two pairs of congruent angles and one pair of congruent sides, but because the congruent side is not in between the two angles, that would be the angle side rule. Okay, so there is a flow chart showing that these two triangles are congruent with one another. All right, now let's move on to the middle section where we need to talk about reflexive property and we need to talk about the vertical angles. All right, so the first thing is the reflexive property. So the reflexive property, if you recall, is a property that says that something in a diagram or in a mathematical situation is congruent to itself. So a lot of people think of the reflexive property as meaning congruent to itself. Okay, so now let's take a look at itself. So let's take a look at these two shapes right here. So my question is triangle ABD congruent with triangle CDB? And you can see, and so what I'll do is I'll outline triangle ABD in yellow, and then I'll outline triangle CDB in blue. Okay, so I'm asking, are these two triangles going to be congruent with each other? Okay, so let's go ahead and let's just make notations about what things are congruent. So you can see that it's marked from the diagram that side A to B is congruent to side C to D. Okay, and that's by those tick marks. It's also marked that side A to D is congruent with side A to D, has the double tick marks, and it's going to be congruent with side C to B. Okay, so what this does is, based on the tick marks, A to B congruent to C to D, that gives me a pair of congruent sides, so I put an S. A to D congruent to C to B, that gives me another pair of congruent sides, so I put another S. Okay, now, if I stopped right here and I said, are these two triangles congruent? You would have to say, no, Mr. Trutna, there's not enough information. There is no such congruence theorem called the SS congruence theorem. Okay, remember the congruence theorems are, we've got side, 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 we've got side, side, we've got angle, side, angle, we've got angle, side, and we've got hypotenuse leg. And remember, these five theorems, they show why two triangles are congruent to each other. Okay, and so right now I have a pair of equal sides and a pair of equal sides. There is no SS rule. All right. However, this is where the reflexive property comes in. All right. So if you notice that in the two triangles, the side B to D in the yellow triangle is the same as side D to B in the blue triangle. Like you could see right in the middle right here from D to B, it is both yellow and blue. So this is kind of weird, but even though it's only one line, what we're saying, it counts as a pair of congruent sides. So we know that side B to D from the yellow triangle is congruent with side, and then I'd have to match it up as D to B in the blue triangle. Okay, so essentially that's a D right there, D to B in the blue triangle, and this is what is known as the reflexive property. All right, so this right here is what is known as the reflexive property. The reflexive property is congruent to itself. So notice B to D is congruent to itself because although it's only one side, it counts as two because it's a side in the yellow and the blue triangle. And that would give me another pair of congruent sides. So going down to the question, Is triangle ABD congruent to triangle CBD? The answer is yes. And the reason would be because of the side, side, side rule. Okay? All right, now let's go over to where we have to incorporate vertical angles. All right, so going down to this problem, the question is triangle BAC, so I'm going to outline that one in yellow, BAC, is it congruent with triangle DEC, which I'm going to outline in blue? Okay, so these two triangles. So let's mark what we know is congruent based upon the given information. So you can see in the yellow triangle, angle B is marked as congruent with angle D. So what that does is that gives me a pair of congruent angles. So in the yellow triangle, the angle B is congruent to angle D in the blue triangle. Okay, also marked in the diagram is that in the yellow triangle, side A to B is marked as congruent with side E to D. And by the way, I would have to say E to D. I could not say D to E because I'm matching up the order that the letters are going. Notice that the B is the same as the D, okay? And that gives me a pair of congruent sides. So in the yellow triangle, side A to B is congruent to side E to D in the blue triangle, okay? And that's all the marks that I have. So right now, if I stopped working, I would say, okay, I have a pair of congruent angles, that's an A. I have a pair of congruent sides, that's an S. But right now, if I stopped, I would say, you know what? These triangles are not congruent to each other. So the answer would be no down here. To the is triangle BAC is congruent to triangle DEC. Okay, it would be no. There's not enough information. However, this is where vertical angles come into play. So if you notice that this angle right here, right at C, that I just highlighted in green, is congruent to the angle opposite of it, which I highlighted in green. So in other words, these two angles right here are going to be congruent with each other. And the reason why they're congruent is because vertical angles. All right. And there's one thing, and we've said it in class, vertical angles will never be marked as congruent in a picture. They'll never be given to you in a picture as congruent. You are responsible for recognizing vertical angles when they show up in a diagram and knowing that they're congruent. So I can now say that triangle or angle, I'm going to name this angle up at the top, and I'm going to name it as angle BCA. I have to use 3 letters to name it. Okay, so that's the triangle up at the top in the yellow triangle, BCA. And that is congruent to the vertical angle right below it in the blue triangle, which I would have to call it angle, and since I went BCA, I would have to say DC, angle DCE. Okay, and that would give me another pair of congruent angles, okay? So these are the same right here. So now I have enough information, all right? I have 2 pairs of congruent angles. I have 1 pair of congruent sides. But now the question is it angle side angle or is it angle angle side? Because notice both of these theorems that prove 2 triangles are congruent to each other, they both have 2 A's and 1 S in them, okay? Now, so what's the difference between the 2? Well, if you notice, the side that is marked congruent in both the blue and the yellow triangle, it's not in between the angles that are marked congruent. So the answer to the question is triangle BAC congruent to triangle DEC? The answer is yes, and you would say because of, and this would be the angle side rule. And once again, it's angle side because the side that's congruent is not in between the 2 angles. Okay? All right, now let's go down and let's review and do a couple examples involving isosceles triangles. So if you recall, an isosceles triangle is a triangle with 2 sides that are equal to each other. So any triangle where 2 sides are congruent to each other. That is an isosceles triangle. All right? So let me draw you a picture of an isosceles triangle. All right, and then now, whenever you have an isosceles triangle, there is another fact that derives from the fact that you have an isosceles triangle, and it has to do with the angles. And the fact that it has to do with the angles is it's very just common knowledge or common sense as to what the fact is. So, and what this says is this: if you have a triangle that has two equal sides, aka an isosceles triangle, then the two angles that are across from the two equal sides, so that bottom right angle and that bottom left angle, those two angles are going to have to be equal to each other. Okay, you guys? So an isosceles triangle, not only will it always have two equal sides, it will also always have two equal angles. All right? And I'm going to write this like this. So if two equal sides, then two equal angles. Okay? Two equal angles. And remember, like I said, the two equal angles will not always be on the bottom. They are called the base angles, but the two equal angles will always be the angles that are across from the two equal sides. Okay, so let's do a couple examples here. We're going to use the fact that a triangle's angles add up to 180 degrees, and we're going to solve for x in each one of the problems here. All right, so let's say that I have this. Here's the first example, the blue triangle, where notice we're going to solve for x, and we have this 50-degree angle here. And then we're going to do another one here where we have the green triangle here. And we're going to solve for y in this green triangle right here. Okay, so we're going to have a y. And I'm going to put a 70 degrees down there. And then we're going to do a third example where we solve for, let's go ahead and solve for w in this triangle here. Okay, and then let's go ahead and do that. Let's put the w down there in the bottom left. And then let's make this angle right up here as 85. Now let's go 84 degrees. We'll keep it even numbers so we don't end up with decimals when we're working out our final solution here. So if you notice, the blue triangle is an isosceles triangle. The green triangle is an isosceles triangle. The gray triangle, all three of them are isosceles triangles. Okay, so we're going to incorporate this rule that says if a triangle has two equal sides, then that same triangle is going to have two equal angles. And the two equal angles will be the angles that are opposite of the two equal sides of the shape of the triangle. Okay, so what this is telling us is, in this first example right here, notice I have two equal sides, which means I'm going to have two equal angles. And the equal angles will be the angles that are opposite of the equal sides. So that means that bottom right angle there would also have to be 50 degrees. Okay, so that means then to solve for x, I just know that 50 plus 50 plus the x angle, all three angles in a triangle always add up to 180 degrees. Okay, so that would be 100 plus x is equal to 180. And then I would subtract 100 from 180, from both sides actually. And you can see that in this example, I would get x is equal to 80 degrees. So this is an example of using the isosceles triangles rule, which says if you have two equal sides, that's an isosceles triangle, then you're going to have two equal angles. Okay, moving to the triangle in green. If you notice, the triangle in green is also an isosceles triangle, as indicated by these two equal sides. So that means that if it has two equal sides, then we're going to have two equal angles. Now, the biggest mistake that people would make in this one is they would say, oh, y is 70. And the reason is because the bottom angles are equal. Okay, well, that's not necessarily true, because remember what I told you is the two equal angles in an isosceles triangle are always the angles that are across from the equal sides. So what that tells me is that this angle up at the top is equal to the angle that is 70 degrees. Okay, so that would be 70 degrees up there. So then that tells me that 70 plus the other 70 plus the angle where the y is, those three angles would add up to 180. And then I would use algebra to solve. So 140 is 70 plus 70. So 140 plus y is 180. And then I would subtract 140. And I would get y is equal to 40. Okay. So this green triangle example is an example of when you have to figure out which two angles are the equal angles in an isosceles triangle. Going to the gray triangle, once again, we have an isosceles triangle. It has two equal sides. So going over here, it says, to the rule, it says if we have two equal sides, then we're going to have two equal angles. And now the question is, which two angles would be equal in this triangle? So remember, the two equal angles are always the angles that are across from the equal sides. So across from this equal side on the right is W. So that means on the left side across from that bottom angle down there would have to be represented as W as well. Okay, so then once I have that, I could write an equation and solve for W. So my equation would be W plus the other W plus the 84 degrees, those three angles would add up to 180. And then I use algebra to solve. Combine the W's together, that would give me 2W plus 84 is equal to 180. I would subtract 84 from each side. Whoops, I didn't mean to put that 1 there. It's just an 84, not a 184. So I would subtract 84 from each side there. Okay, and that would give me 2W is equal to 96. And then I would divide by 2. And W would turn out to be equal to 48. Okay, so there's an example of putting to use the two angles are equal whenever you have two equal sides, which we call the isosceles triangle rule.